All right, folks. In this section, we're going to be talking about assessing risk. This is 7D. And really, this is more about assessing risk in the media or interpretation of different statistics in the media, specifically vital statistics, and we'll talk about what those are. So, we're going to start out with a little example. An honest salesman comes to you offering a new product and says, I can't reveal the details yet, but you'll love this product. It'll improve your life in more ways than you can count. Its only downside is that it will eventually kill everyone who uses it. And then, will you buy one? So, probably not at that point. Comes back a few weeks later, no one was buying, so we've made a few improvements. Your chance of being killed by the product is only 1 in 10. Ready to buy? He returns again. This time we perfected it. We made it so safe that it would take almost 30 years for it to kill as many people as live in San Francisco, and it can be yours for a mere $30,000. So, what is he selling? Selling a car. All right, so let's look at risk and travel. So, is driving getting safer? So, the height of the orange bars represent the number of deaths on the left axis here. And then we've overlaid a time plot where that line represents vehicle miles driven on the right axis. So the reason we need to compare both of these things, right, is that between 1970 and 2011, a lot of things changed. The population grew, which means there are going to be more cars on the road, which means there are going to be more fatalities, period. So we can't just look at fatalities over time, although you are seeing that decrease as a whole, even though population and cars have increased over time. But what you want to compare that to kind of get a baseline for comparison is vehicle miles driven, and this is in millions. And so the line graph, we're looking at the blue line and the right axis. So as you can see, because population increases over time and cars increase on the road, as time went on, we had more vehicles driving, thus more vehicle miles, steadily increasing, right? And as I said before, we had that nice steady kind of decrease in overall deaths by automobile. So what we want to do is compare the ratio of deaths to miles for 1970 and 2011. And when we do that division, you can see what we get down here. They're both in scientific notation and times 10 to the negative 8. So you can really just ignore the scientific notation part of it and focus on comparing these two numbers. And so when we do that, if I want to see maybe a relative change, I can just do 4.7 minus the 1.1 divided by the 4.7. And that's going to give me about 0.765, meaning there's been a 76% decrease in deaths by auto accident from 1970 to 2011. So yeah, it's pretty safe to assume that driving has gotten safer over the past half decade or so, and or sorry, half century rather. And this notes that research believe these improvements are from better automobile design and safety features such as seatbelts and airbags that became mandated in the last 2 decades, 3 decades maybe. All right, so data concerning births and deaths of citizens are called vital statistics, and insurance companies use these to assess risks and set rates. So we were talking about in the last lesson, insurance companies making those expected value calculations, and they actually make those expected value calculations by finding probabilities using vital statistics. So assuming a U.S. population of 315 million, find and interpret risks per person and per 100,000 people for accidents and suicide. So if we first look at accidents, 122,800 in 2011. Divide that into 315 million people, and we get 0.00039 deaths per person. So that unit of measure doesn't really make any sense to us intuitively, which is why we multiply it by 100,000 to make it deaths per 100,000 people. That just makes it a little bit more of an intuitive unit of measure, meaning about 39 deaths per 100,000 people on average are due to accidents. And then suicide, same idea. Take the numbers for suicide, 38,300 divided into the 315 million people, and we get this, again, number 0.00012 death per person. Again, not very intuitive, so multiply it by 100,000. So about 12 deaths due to suicide per 100,000 people on average. Cool. All right, life expectancy. This is a definition you need. It's the number of additional years a person of a given age today can expect to live on average. So a lot of times when we talk about life expectancy, we talk about it at birth, and that's just total lifespan. But you can talk about it for any year. And this is the time plot of life expectancy at birth since 1900 to the last decade, 2010, right? So you can see it's steadily risen. This is due to a few things, largely due to safety regulations, better health care, better medical science, etc. All right, so I'm going to use the figure here at the right to find the life expectancy of a 20-year-old person and a 60-year-old person, and are the numbers consistent? So all we would do for life expectancy for a 20-year-old person is go straight up till we hit the line, then over. So you can see it's about 60 years for a 20-year-old, and then meaning on average they're likely to live till about 80, and then for a 60-year-old, up to the line and over, it's a little above the 20, so about 23 years, meaning they can expect to live to about 83. So why are the numbers different? Well, the idea is there's more variability when you're 20, you're younger. So depending on how you live your life, your diet, alcohol consumption, smoking habit, whatever, all these things can contribute over the long run to different life expectancies. So there's more variability. But once you get to be 60, you're older, you've already made it that far. So you've already been making some life decisions that got you there. You're more likely to live a little longer at that point. All right. Using that figure, determine how much life expectancies rose in the 20th century, and suppose that life expectancies rise by the same amount during this century. What will life expectancies at birth be for children who were born in the year 2100? So if we look at this chart, and over the last century from the year 1900 to the year 2000, so it looks like men are at about, men are about 75, women are close to 80 there. Here, both well below 50, maybe like 46 and 47, men and women respectively. And so the way we can see this is for women, that's a difference of 32 years, meaning life expectancy increased by 32 years. And for men, life expectancy increased by 28 years. And if that same increase occurs in the year 200, women go from 80 years to 112, and men go from 74 years to 102. So if life expectancies continued their trend from the 20th century, there's a good chance that today's high school and college students will live to average ages of over 100 for men and 110 for women. Um, I, they can't continue to increase linearly necessarily as we kind of approach the singularity in terms of uh, medical science. But good news for you guys, right? Over 100 and 110. All right, that's it. So pretty short lesson for this one. Work through the problem set, and you'll be turning in the homework via the Canvas quiz link. Take it easy.